Hello everybody, welcome to the room correction talk. I'd like to tell you a little bit about our panel here. This is Tony Knight. He's a local member of the community, the only member of the panel that's not commercially interested in audio. Tony's background is that he's started off his career teaching physics, ended up working in the space program, worked at Martin Marietta here in Colorado, got an award from NASA for his work, and is now currently retired. Tony is an avid audio enthusiast. Tony has one of the finest listening rooms I've ever experienced, and Tony is an early adopter of electronic room correction. And Tony will have a lot to say about that and has some graphs that are being passed out. We were going to display that on the screen here, but we seem to have run into some technical difficulties, so we're going to avoid that. On my far right and your left is Richard Reeves Berg from Reeves Audio. Richard is expert in room acoustics. His company, Reeves Audio, designs rooms for people, for home theater, music, and his company has designed a bass room correction box. Is that parametric EQ? Parametric EQ for the bass. So not only does Richard know about designing rooms and correcting for bass, but he integrates all of these things together. And to my immediate right is Mr. Duke LeJeune from Audio Kinesis. Duke designs speakers to work in your room, which I'm sure as you've been wandering around the show, you've seen a lot and heard a lot of speakers that aren't really designed to work in rooms. And we've had plenty of experience with that over the last couple of days. My name's Neal Berg. I own Sound Science. I'm a local retailer here in Colorado, design music servers, and have experimented with speakers. My interest in all of this came when my wife and I moved into a new house, and my rather elaborate, wonderful stereo, I could no longer understand anything Bruce Springsteen had to say when he was singing to me, and had to take immediate steps to rectify that situation. At the time, I worked for Agilent Technologies, brought home a $30,000 FFT analyzer, measuring microphones, and went to work. Went to the Guitar Center, picked up an inexpensive used 31-band stereo equalizer, and after an hour and a half of aggravating my family, achieved small miracles in what I was able to hear. And that started my path on and my interest in room correction. So with that, I think each of us are going to tell you a little bit about what they think is important in the room, and then we're going to open that up to questions from the audience. So Richard, would you like to start?
As Neal already said, I'm the founder of Reeves Audio, and we design listening rooms, theaters, and multi-purpose rooms all over the world. We do it through a dealer network. We've designed over 1,000 rooms at this point. And one of the things that I feel is very important in designing is listening to the client. People have different preferences, different tastes, and people often come to me and say, are you dealing with an art or a science? And the fact of the matter is it's a little bit of both. And if you understand your customer and you understand how they listen and what they listen to, you're much more likely to achieve a satisfactory result for that particular customer. So one customer may have a different result than another customer. And I think that's very important. And that also goes to the point of aesthetics and dealing with what I refer to as real-world issues. We are not the dogmatic type of company that says, okay, your listening position absolutely has to be in this location, and your speakers absolutely have to be in this location, and you absolutely have to have the following things or nothing's going to work. Real world, most of us do not have dedicated listening rooms, and so you have some real world challenges that you have to balance with how you live versus being able to achieve absolute maximum possible acoustics. So with that, I will hand it over to Duke.
Thank you, Richard. Is this working? Okay. My first time with the microphone, I think. Okay. My area is loudspeaker design for intended to be room friendly and room correction friendly. The two are actually quite similar. A digital room correction system can solve a lot of the problems that a speaker has, with the two problems that it cannot solve. One is the inherent physical limitations of the speaker, mechanical and thermal, and the other is its radiation pattern, and that's what I'm going to focus on, is the radiation pattern. Ideally, what we'd like, okay, the reason the radiation pattern matters is because the reverberant sound in the room matters. The reverberant sound plays a significant role in perceived timbre, spaciousness, richness, and liveliness, and if we screw it up, the reverberant field can greatly increase listening fatigue, or make it more rapid in onset. So, oh yes, thank you. Okay, is this better? Yes. Okay, okay. The first part wasn't important, so you don't have to. You didn't hear it. Okay, what we want as far as is the reverberant field is we'd like the reverberant field in the room to have approximately the same spectral balance as the first arrival sound from the speakers. We'd like it to start arriving as late as possible after that first arrival sound. I mean, we'd like it to be highly diffuse. The part I'm going to focus on mostly is the spectral content. The way we get the spectral content of the reverberant field to be similar to the first arrival sound is having a loudspeaker whose radiation pattern doesn't change a lot with frequency. Now, unfortunately, loudspeaker radiation patterns inherently change with frequency. It's called beaming. I'm sure everybody's familiar with that. So what we'd like to do is look for speakers that are taking steps to minimize beaming. In Pro Sound, one of the things they do is they use a horn-type mid-range tweeter unit. These three-way systems, you see the ATC powered monitors, they're taking steps to do that. They're using it's a three-way system where the size of the drivers is one of them is about 3 times as big as the other, and the next one's about 3 times as big as that one. And if they play around with the crossover right, that type of system can do a very good job of creating a reverberant field that sounds a lot like the first arrival sound. Okay, there's a special case in audio, home audio, of what's happening in the bass region. The bass region, as you all know, we have peaks and dips that can be very annoying and they're difficult to solve. The approach that I like to use for that is rather unorthodox. I like to use multiple subwoofer systems, four small subwoofers scattered asymmetrically around the room. That way each one will produce a different peak and dip pattern at the listening position. And the sum of all these different peak and dip patterns will be smoother than any one alone. Now, this works, both of these techniques work well in conjunction with the room correction system, because the multi-sub system, what it does is gives you smoother frequency response in the bass region, but perhaps even more important, less spatial variation. The sound of the bass here is not going to be as different from the sound of the bass over there. So when you solve a problem here, you're probably either solving a problem or at least not making it a whole lot worse over there. So that's an advantage of the multi-sub system. As far as getting the reverberant field similar to the direct sound, that can be difficult to achieve, but just because the radiation pattern thing is hard to do. But there are a lot of speakers that get the power response right. The power response is the sum total omnidirectional output of the speaker. And a prime example of a speaker that paid a lot of attention to that was the BBC LS3 5A. You've heard of the BBC dip. Okay, what the BBC dip was, it was a dip in the on-axis response on the tweeter side of the crossover. See, the tweeter's going to have a much wider pattern than the woofer. So we're going to put an on-axis response on the tweeter side of the crossover, and what that'll do is sort of equalize out the extra energy the tweeter's putting out off-axis. So that will give us a good power response. So anyway, with that, I should probably pass the mic. Thank you all.
Tony's got it.
Okay. I've got a handout here that you probably will need. I guess there are a lot of people who've come in who don't have a copy of this. If I can just get someone to pass it around,
Tony,
because it's got a list of figures. Now, one of the things when you come to an audio show like this, you realize that if anyone needs room correction, it's audio shows. You walk around and you hear all these speakers, and there's all the bass resonance and the people next door and God knows what else. So room correction is, I think, an essential part of any real high fidelity system. Now, my first entry into high fidelity was back when I bought one of the now legendary Decca cartridges with professional arm back in 1963, I think it was, when they were released. And so my system has been changing since then. Currently, I have a multi-channel system that is in a dedicated room I designed and built in my basement. And I use a computer with 64-bit precision for computing the various correction curves. And I use a program called Accurate, which was written by Dr. Brueggemann. And there's a link to that on the handout. And I find it to be the most effective of the room correction systems. When I designed my room, I had a very specific goal in mind. And I think if you get into room correction, you need to have one yourself. And my particular goal was I wanted to put the listener in the same space as the recording rather than bring the orchestra or what have you into my room. And in order to do that, you need to essentially do everything you can to take the room out of the equation. And so I did everything I could. And if you look at the figures on the back, you will see figure 1 is the way the RT60s, that is, well, you can't have an RT60 in a room, in a small room, but this is derived from the rate of decay. And you see that, from about 90 hertz on up, the RT60 is somewhere between 150 and 200 milliseconds. And that is very much less than a conventional wisdom will tell you it ought to be, but I can assure you it ends up sounding just fine. When I got into room correction, it was with a tact unit, a 2.2x, and that works reasonably well. There are problems with it that were never resolved, but it gives you an idea what you can do. And then I transitioned about 3 years ago to an accurate system. And if we look at figure 2, which is the brightly colored one, that shows the impulse response on my system as an S transform. And that tends to spread out the impulse, particularly in the lower frequencies. But I think you can see from that the effect of the room is very small indeed. There's a small bass mode that came from an unanticipated resonance that I have. But apart from that, you can see an extremely clean representation. And to get that, you have to have both room treatment and DSP correction. And if we turn over, well, not turn over, go to figure 3, it shows the frequency response of my system measured at the listening position. And you can see that it's flat from about 6 hertz to about 17 kilohertz. The blue curve is the total harmonic distortion, and you can see there that I still had work to do in the crossover region. Bass, I've got the subwoofer impulse response next, and you can see there probably one of the cleanest subwoofer responses you've ever seen in your life. And also a point to note is that there's been a lot of talk recently about pre-ringing in digital filters. Well, you don't have to have a digital filter with pre-ringing. The filters I'm using here are Bessel filters, which have no pre-ringing and no post-ringing, so they're absolutely clean. And the final thing is the main speaker impulse response, which is that from my quads. I have 2905s for front left and front right, and 989s for the two rear channels and the center front channel. And you can see there, clean impulse response, relatively little room effect. You can only get that sort of performance from the system if you do a sensible job of your room treatment and with use of DSP room correction. Now, perhaps one last word. As you walk around and listen to the sorts of things people are listening to, you find that it's very much a matter of what people like to hear. You know, I'm the old school. To me, a system is good when what you hear at the listening position is what is actually on the recording. If you prefer to have a tailored and contoured sound, you're still better off with a good DSP system because you can balance both left and the right speakers, and it improves your imaging no end. Hopefully we've said enough to get you started on some questions.
Warren.
What is RT60, please?
It's a time for the sound to decay by 60 dB.
What kind of treatments did you employ in the room? I know you said it was a composite.
Warren, can you talk a little, just a little bit louder for us?
I'll repeat the question. Sure. My question is, what kind of treatments did you employ in your room?
Okay.
How did you design your room?
Okay. The first thing I did when I designed the room was I wrote myself a little program to compute reflection points. And so I had a range of positions for speakers, a range of positions for the listener. And so I worked through reflection points because those affect the imaging significantly. And so I essentially traced for an omnidirectional source around a rectangular room to see where various reflections were. And so I could then put absorber in the region of highest density of reflections and then rerun it again and see where reflections were. And I worked my way through that. And basically, well, that was a reflection issue. Then there's the issue of bass response. I put a lot of effort into trying to eliminate room modes as best I could. The only real way to eliminate room modes is by some tuned absorption. Now, some time ago, Threshold came out with a device that was active and cancelled room, and that's coming out again now. But I designed in a significant amount of Helmholtz slot absorbers, and essentially the whole of the front of my room, front being where you face, the wall behind the speakers, all of that is essentially both a Helmholtz slot absorber, and also it has 8 inches of foam broadband absorber between the various slots. I've got a lot of quarter wave absorbers in the ceiling structure because there are the joists above the room, so you can close off in appropriate places in the joists and seal the bottom, and come up with a quarter wave bass trap. So I did a lot of tuned bass absorption. So to a large extent, the front of my room, and you can see that on the handout, the front of the room, the slots that you see there are the Helmholtz slot absorber, the fronts of the Helmholtz slot absorbers. Between them is the absorber, 8 inches thick absorber. Then at the sides, sort of halfway up the wall, you can see absorber panels. And then closest to you, you can see what is in fact behind the listener, which is diffusing. Basically, the whole of the rear of the room is diffuser. The ones that look like paneling, for those of you who have a wife, my wife likes it, are in fact high-frequency diffuser panels, Schroeder diffusers. And right at the back of the room, I've got some diffusers that go down to about 200 hertz.
It's fair to say that it's non-trivial what Tony's done.
Yeah. You know, if you're local, on the handout I've put in a email address that you can get hold of me if you want to. But if you're local and you're interested, you can come and take a listen in my room and see what you think.
Yes.
A question regarding DSP. I understand, of course, first, a nice shaped room and absorption and diffusion is what you probably want to do first. But when I've worked with DSP, it ends up sounding a bit digital. I end up with a good timing, a good frequency response, but in the end you go, wow, that still sounds very digital, even though on paper everything looks good. Any comments, suggestions?
Well, I sell a variety of room correction systems, and I don't know what you're using or what you've got or how old the technology is, but I have not experienced that at all. So it could be impossibilities with your room that make it just really difficult. It could be an application where maybe something just wasn't done right. I mean, I'm not accusing you of not doing it right, but it's not an experience I've had. If you go over to Tony's house, if you're local, you won't hear any digital artifacts whatsoever.
You're saying it doesn't affect the transparency at all, having that in the chain?
No, but
no, not at all.
Not at all. Keep in.
I would say that in Tony's, what Tony has done is, and I have not heard it, but I've talked to a few people that have, and he's created a system very transparent using vessel filters. There are also other filters, IIR and FIR, which are often used. FIR filters, and I think Tony can also attest to this, can have some significant problems in the higher frequency ranges, and it depends on how they're implemented. So that the problems can arise from that. And Tony, maybe you want to comment on the different filters.
Well, everything has potential problems, including analog, for example. And in a digital system, you need to have sufficient precision in your computations. A lot of the early devices really don't have enough precision to avoid adding something to the music that you're listening to. So if you're dealing with something that's relatively old, there certainly is a potential that you will have some problems, particularly in the higher frequencies. And the other thing that you need to think about is most of the devices that are on the market are made in such a way that the computational time is of the order of 20 milliseconds or less. And the reason for that is if you want to use it with a video system, if you have a much longer delay than that, you will end up losing lip sync. And when you limit your corrections, you tend to limit the precision of what you do. Now, the tact, for example, it splits the spectrum up into 3 regions. It computes each region independently, and then it slots them back together. And it has 1,024 coefficients for the higher frequency and 2048 for the others. Now, doing that, they have about a 20 millisecond delay in going through the system. Now, since mine is an audio-only system, it really doesn't matter how long it takes to do the processing. It just means the music starts, and then half a second later, it starts to come out of the speakers. And so with that, I've experimented with up to 524,288 coefficients, which, it's a wonderful hobby, because in the old days you used to change a transistor and see if it sounded better. Now you can go in and change what you're doing with your DSP, and it costs you absolutely nothing.
Thank you.
Yes, sir.
I guess 2 questions for Tony, if I could. One, you say you want to take the room out of the equation, but not entirely, obviously, because you didn't build an anechoic chamber. But so the RTA60 that you got, the RTA60 150 to 200, was that a goal you had because you believed that would be the best sounding, or did you build the room and it ended up being 150 to 200?
Both. It was, my goal was to get it down more or less as low as I could. But when you do this sort of thing, there are so many compromises you have to make that there's a lot of judgment that one needs to apply, as well as computation. It's like, I'm a firm believer that one measures and one listens. The two are complementary. And the same thing is true there. It's a matter of deciding how you're going to compromise. And so when I compromised with all the things using best judgment, that's what I got.
Can I just follow up briefly? It seems like you also, based on this description, optimized for a fairly small 1 seat, 2 seats or something, as opposed to, I'm thinking of Floyd Toole's book, where he spends a lot of time talking about a rather larger area, in which obviously there's some compromises there.
Okay, well, yeah, there are compromises. When you take a measurement at a position, you're measuring at that position. And then not only are you measuring at that position, but depending on how you analyze the impulse, you can get very different results. And what you correct to is the result that you get when you decide how you want to work the impulse. Now, all of the commercial systems essentially do it one way. And that's why sometimes commercial systems don't work too well in the room. But, it's once you move away from that point, you're going to have something different. And of course, the same is absolutely true whether you use DSP or not. It's going to be different. And I've got a graph here, which unfortunately we can't show, but it's the difference between the inputs with a room corrected and a room not corrected. This is, I don't know if you can see this well, this is just a correction with one of my quads. And the quads don't go down much below 30 hertz on this, but reasonably flat out to 17 kilohertz. Total harmonic distortion about minus 43 dB. That's about 0.7% maximum. So that is a corrected curve. An uncorrected curve looks like this, the way I've got it in my room. That's if you can see it. It's all over the place. I have them positioned by where I want to put them, not by where they sound best. So then, where are we? I then measured 2 feet to the side. And the difference between the corrected one in the center location and 2 feet from the side is, which one is it? It's a black curve. It goes like this. And for the uncorrected, it goes like this. They're different, but they're both, the worst case is different by 12 dB, and that's 2 feet away from the center. So there are attempts to make measurements over a broader spectrum and average it, but if you really want the highest quality, you do it for the one seat.
Far back.
I just want to expand on something Tony said at the very end. You said one of the big advantages of being able to correct for left and right. And I just wanted to expand on how useful that is in most home environments, because your systems aren't necessarily set up symmetrically in the room. And even if they are, the furniture in the room isn't symmetrical. And so being able to correct separately for left and right, or if you go active, to correct separately for the individual drivers can really be a big advantage for that. And also, it can correct for discrepancies in drivers. I mean, the manufacturer's drivers, the same driver don't always operate exactly the same. There has to be some sort of quality control there. And the DSP can actually compensate for differences in the same drivers.
Exactly. You, sir.
So if I'm new at room correction, and I want to ask a very 101 type question. My understanding is there are basically 2 tools to use, just diffusion and absorption. And when you absorb, you're trying to take out reflected waves that are building in amplitude. And that's all you want to take out, because if you over-absorb, you're taking information, correct?
No. If you over-absorb, you're really not taking out information. The way the ear works is that it's optimized really as a protection mechanism. So the snapping twig syndrome. So it's very responsive to initial transients and the direct sound. And that's what carries most of the information. Now, if you absorb stuff that's around you, you can walk into one of these rooms and you feel as though you're like this with the sound. You're really getting rid of that part of it. Does that answer what you were asking?
Yeah, I think so. The concern is you don't want to bleed the life and vitality out of the resonance of the music. What people did a while ago was they threw a lot of fiberglass insulation around their rooms, and it's very easy to kill the high frequencies but do nothing with the lower frequencies. And that's basically what you get when you get what you call a dead room. The key is to try and, where you do have absorbers, to make them as thick as you reasonably can, so you push the absorption down into the mid-range. And if you get a balance across the frequency range, that, if anything, I think is more important than the absolute value you get from the standpoint of listening. I pushed it down a long way because I wanted to hear the ambience in the actual recording rather than have my room swamp it.
there's little bit of difference of opinion, which is why panel discussions are fun. I have a bit of a different philosophy than Tony does on this, but before I get into that, I have one question for Tony that I think is very important about this. Your system is multi-channel, pretty much predominantly multi-channel is what you use?
Well, no, I've got a lot of CDs.
So a lot of two-channel too?
A lot of two-channel.
Okay. Well, in our design philosophy, we're generally, for two-channel, looking at reverberation times on the order of 350 to 380 milliseconds. Quite a bit higher than Tony's room. In multi-channel, we're usually looking for 250 to 300 milliseconds is the reverberation time. The room does add certain ambient cues that for most people it is more comfortable, certainly for myself. I have been in rooms that are designed and well designed like Tony's. I mean, one of the things that is very important that Tony has done is he's kept the reverberation times fairly consistent across the bandwidth, and that's important no matter what the reverberation time is, whether it's 150, 250, or 400 milliseconds. Having a consistent decay across the bandwidth is important, which is what Tony was talking about. If you do only 2 inches of fiberglass, well, you're only going to be affecting your high frequencies. You're really going to have no effect on your mid-range, and certainly not on your upper bass region. But with that, having been in, I have not been in Tony's room, but having been in other rooms that did have very short decay times, it was not an enjoyable listening experience for me. And that's why I say something that is important for us is to understand your clients. And one thing that's important as a client is to get exposed to as much of this as possible. Listen in different environments, listen in different things. If you are local, it would be interesting to listen in Tony's room, and I actually wish I had had the opportunity to do that before I came here, because I feel like I could speak much better on this portion. But at any rate, I do want to bring up that there are different design philosophies on what the correct target value for reverberation time is.
Far right.
I was just curious of the actual room dimensions of your room and your listening position within that room. How far away you are from the front, speaker end of the room, and actually how wide your sweet spot you've been able to design in. Is it really extremely focused where you have a single listener position, or are you able to get a little width with what you've done?
The dimensions of the room were really determined by the size that was available to me in the basement. So it started off with being about roughly 30 feet by 12 feet. By the time I'd finished putting in the Helmholtz slot absorbers, which take up a lot of space, the physical size of the room is about 24 feet by 11.5. There's a heating duct that runs across the room. So across the center of the room, the height is only about 6 foot 6 inches. And the rest of the room, it's about between 7.5 and 8. It is nowhere near the dimensions I would choose if I had a free hand. But one of the remarkable things is how well it sounds being as it is. The subwoofers are built into the end wall that has the Helmholtz slot absorbers, and essentially they're tied to the concrete behind them. I use very small volume subwoofers. I got 15-inch drivers in about 1 cubic foot enclosure. And what that does is it drives the resonant frequency of the driver up around sort of 80 or 90 hertz. And so I operate my subwoofers entirely below the resonant frequency. The quads are typically 5 or 6 feet in front of the wall behind them. And my listening position is typically about 9 feet from each quad.
Thank you. I asked because it looks like a wide-angle lens is 10 feet.
It's a very wide-angle lens that really distorts.
I would have never guessed it was 11 foot wide.
Right. It's a very wide-angle lens. I should have mentioned it to you.
Yes, sir.
I realize that, like Reeves was saying, there's a lot of different goals in terms of what people are after and the ultimate sound of the rooms. But I think one of the decisions that a person who tries to DIY some room treatments for himself is there's always this choice between absorption and diffraction and diffusion. Are there any, I know there's, based on the different effects, you're going to choose different strategies, but are there any sort of agreed upon universal situations where one chooses, diffusion or absorption in certain positions? Like, I mean, are there some things that are common to almost everybody's,
To a small degree, yes. I think, let me repeat the question slightly and make sure I understand. What you're saying is you have these various tools, and you primarily mentioned absorption and diffusion. I'm going to take it a little further than that. And the question is, where do we put what things? Is there a general rule of thumb? There are some general rules of thumb. However, they do change with the volume of the room. The first thing to keep in mind is, in general, in most of the rooms we design, the absorption is generally going to be relatively thin and thus dealing solely with the upper frequencies. The midband is generally dealt with diffusion, and the low frequencies are dealt with, you didn't mention, but some type of low frequency trapping mechanism. The low frequencies are pretty straightforward. There are a variety of tools we use, quarter wavelength disruption or trapping, and corner disruption. We often use what we refer to as a capacitive style trapping mechanism, and what that does is it's kind of like a giant drum that takes energy in and then re-releases it. And so what we're trying to achieve is a larger sweet spot where you can sit in multiple areas and have a more or less uniform bass response. It's not a perfect system, but it does definitely give you a much bigger area to be able to, and you can imagine in a family environment or theater or something, that's a goal that we're often after. In terms of diffusion in the midband, you almost can't do too much. I mean, that's the one area that you can put in a lot of diffusion, and it's rare that it really starts to adversely affect things. Now, you always want to deal with first reflection points, but how you deal with first reflection points can change depending on the room size, how close the speakers are to those reflection points. So absorption versus diffusion in those locations varies. But you'll almost always have one of the two.
And I think Richard's got a tough job because speakers like Duke designs, where they're controlled radiation pattern, the room treatment you require is going to be different than if you've got an omni radiator like an MBL or something like that.
Yeah, that's right, versus planar. They have a different radiating pattern as well. And then the other thing, which I haven't really mentioned, well, I mentioned briefly in my opening statement, is how people listen. And so the person that's in a small room that wants to listen to rock music at 120 decibels, we're going to have a much shorter decay time in that room for it to be controlled, versus somebody that wants to listen to chamber music in a 18 by 30 room. The longer reverberation time will add to the ambience of that chamber music.
Yeah, I would say as a general rule of thumb, go for absorption in front of you and diffusion behind you.
And I'm the exact opposite. This is why panel discussions are fun. And so, but I do want to, I like this part. This is something that's often asked, and it's the old, and I think Tony and I probably, we may have different, and lots of people are this way. You have different things you cue in on when you listen to music, and you listen for different reasons in different ways. Tony has essentially, in many respects, eliminated the room. And there is a philosophy out there that this is a good and wise thing to do, that you want to get into the final nuances of the recording and not have the room. But I personally don't want to listen in an anechoic chamber and listen at that. I want to listen to a sound stage where the music, I feel there are the performers right in front of me, and some of those reverberant sound cues help create that illusion. Okay? So I'm not about to say one is right or one is wrong, but I will give you my philosophy on what Tony is talking about, which I'm going to go back to live in, dead in. Many people, I bet you everybody in here, probably most people have heard of live in, dead in. It originated out of the 60s, and it was out of the recording industry. And what they did was, in the recording world, an engineer is sitting there with a pair of monitors. Behind the monitors was the dead end, just like what Tony is mentioning. I'm going to make that absorption. And behind the recording engineer was diffusion, and that was breaking up any reflections or sound that would come back there. Well, when you start to think about, let's think about the performance in general. Let's say we have a symphony up on stage. The stage is live, somewhat diffusive, but it's live. It's sending that information out. The microphones are hanging in space. You know, a really good, like the Mercury Presence recordings where the mics would, just two mics, very simple system, or three oftentimes, but a very simple system. And then it's all absorptive behind it. All the people and everything behind it create an absorption. Now, we take that, we're capturing that information. Now we're going back into the recording engineer's world. And the recording engineer wants to hear, he's using this as a tool, he wants to hear his monitors giving him back what those microphones were capturing. So now we've inverted. We've gone from live end on performance to dead behind the microphones. We're inverting that. Now the monitors are bringing the mics out. It's dead behind the monitors. It's live behind the recording engineer's head. Now we're going to make this piece of music, and we're going to put it back into our living room. Our living room live, but diffusive. Don't make it a live, flat surface. It's going to give you this echo impulse response. It's going to be horrible. But it's more live on that end, and once it gets behind me, I don't really want it coming back at me. So just a little bit of difference.
And I think...
You want me to?
It's fine, yeah. I think this makes it more interesting.
You see, if you are in a concert hall and the orchestra is in front of you, has it fallen off? Oh, okay. If you're in a concert hall and you have it live in front of you, in general, the very earliest first reflection you're going to get is at around 20 milliseconds in a good hall. And that is basically the criteria I set for reflections when I was designing the room, to eliminate all reflections at less than 20 milliseconds. And as it turned out, there were 119 different paths in my room where I got reflections at less than 20 milliseconds. But what we have now is the speakers, and what is coming out of the speakers is in fact what is live in front of you in a concert hall, hopefully. And so you don't want to screw that up in any way. And that is why in getting rid of all of the reflections, the front of the room ends up in being absorptive. Now, what comes from behind, you don't want to absorb too much of the sound, or the room really does get too screwed up. So that is a good place for the diffusion. And basically, target the absorber in front of you to get rid of all of the reflections, so you can hear the direct sound from the speakers that is the orchestra playing for you. And then behind you, have it all diffusive, so you get no direct reflections, and it adds to the spaciousness of the presentation. That's basically how I analyze it.
And that is, I think that's, that's a valid way, but there's a couple of differences here. One is you have to sit in one very precise location between those two speakers. In many of the times we don't do that. When you sit in front of an orchestra, it's like an array of speakers. It's a whole bunch of instruments all in front of you. But when we go into our living room, we have, and I'm speaking primarily right now of just two-channel, so let's take multi-channel out of it for a moment, because it can add a lot of spatial cues. But now we have just two speakers, and we have to create the illusion that there's a sound stage up there, that lots of this is going on. And so some of those short early reflections, if controlled properly, if you don't control it properly, it's going to be a train wreck, and it's going to sound absolutely horrible. But some of those can, in my viewpoint and our designs, help create that illusion.
Sound stage is imaginary in any case. You don't get sound stage on a recording. Sound stage is created by your room. And your situation is different in that you're looking for a wider listening area, and that drives slight differences in the design. I'm looking specifically for a very good central area, and irrespective of anything else, the off-center is still pretty darn good. In fact, say, Roger,
sir,
you've listened off-center in my room a lot.
Yes.
Would you like to make a comment on what it's like?
Sounds wonderful. Tony's music room provides the most realistic music I've ever heard. And I envy
Including what?
And I envy him immensely. Not including.
Chuck.
Could you speak? I'm very familiar with Tony's room also.
Speak up.
I'm very familiar with Tony's room also. And I actually had the experience of listening to fundamentally duplicate systems in the room immediately above his basement, where his system used to be, and immediately below, and in the basement after he created the room. And I could listen to a recording in this more reverberant space upstairs, take the recording right downstairs immediately, and listen to it again, and see what the effect of his room treatment was on the recording. Very interesting experience. I heard the original hall where the recording was made unbelievably clearly. This huge space in the treated room. Upstairs, I heard his room. The upstairs room, the reverberant room. Now, I believe that the brain creates a sort of a filter that enables you, and you adapt, you adjust yourself to the reverberant sound field that you're listening to. In other words, the room that you listen to, you listen to your stereo system in all the time. You gradually get used to the influence of the room on the sound. And you are able to hear pretty good in that room, and things sound like real music, like natural. And you can make small changes and hear them very precisely. But what you can't hear is the wealth of material that is on the recording, wealth of ambient material that is on the recording. Instead, you hear this combination of what's on the recording plus the influence of your room. So Tony's goal is to hear what is on the recording. Nothing more, nothing less. Because he likes the sound of those damn halls, you know, in Germany or in England or wherever. And so it's a matter of opinion, which kind of space you actually like better. But if your goal is to hear exactly what's on the recording and hear the original acoustic space, my experience in Tony's house is the downstairs room, the basement room, the treated room.
Okay, we've got 5 minutes left. So, yes, sir.
I'm just curious what these 3 horizontal panels are here on the floor between you and the speaker.
Oh, well, they were just an attempt to attenuate the floor reflection a little.
So you keep those there?
Yes. They're not as effective as one might hope because the wavelength of the floor reflection is such that it doesn't see them too well.
Would you like to say anything about the speakers?
Okay. Are we on? Okay. Yeah. Most of my dealings are with people who do not have a room anywhere approaching what Tony is doing. I have one question, Tony. In listening to 2-channel, are you synthesizing for the rear channels a signal, or is it only coming from the left and right front speakers?
Currently, it's only coming from the left and right front.
Okay.
I have experimented with synthesizing rear channel information. Yeah, I have one of these JVC devices that came out about 8 or 9 years ago, and I've taken a look at the impulse responses from that and regenerated them with an accurate filter.
Okay.
And I've not yet got it to a stage where I'm comfortable with it.
Okay.
So currently 2-channel, I just listen to left and right front.
Okay, thank you. The way a loudspeaker design might apply to what we're talking about here is if the speaker has directional characteristics that minimize those early reflections. Usually 20 milliseconds is hard to get in one of our home rooms. 10 milliseconds is probably more realistic. That can help, that can move things more to where diffusion is a more practical solution than absorption. Okay, you see that Tony is addressing the floor bounce. The floor bounce and the ceiling bounce, those happen too soon for this type of speaker to avoid. If you have a line source or a line array, that can avoid the floor and ceiling bounce. And so that's an area in which that type of design works very well. Any questions about speakers?
Neal, would you tell us something about your product and how it works?
Okay. Yeah, so quickly, the Lingdorf room correction systems, you do measurements around your room with the included microphone. It calculates what your room is doing to the sound, okay? And it will create an inverse filter for the room. It leaves the frequency response of your speaker alone, okay? So it's not trying to give you a certain frequency response. It's just trying to remove the response of your room. So you don't get any particularly digital effects. It's not quite as effective as the accurate system that Tony is using, but on the other hand, it's really easy to do, and in 20 minutes you've improved your room dramatically, much more than you could do with cables of any price.
Well, how do you do that if you don't affect the frequency response?
Well, what you're doing is you're calculating what the room is doing to the frequency response of your speakers and inverting that. So you're essentially, if you can think of it this way. You calculate the transfer function of your room and then invert that and apply that to the signal going into your speakers. Okay? So in summary, I think that all three things are really critical for getting a great sound in your home. You want to do whatever you can afford to do to the room to make it better, because no matter what you do electronically, the more perfect your room is for the way you want to listen to music, the more effective the electronic room correction is. And even regardless of your skill level, it's not possible to mechanically build a perfect listening room. I mean, if you want to hear what that sounds like, take your stereo outside with no reflections, no walls, and that's the best it will ever sound. And if you choose wisely in your loudspeakers, you'll need less room correction than if you don't. I want to thank you all for coming, and see you next time.